The part number 4 in our calculation is going to be about the power in machining. So we go back to the same equation. You can see that this is a full equation now. We do have the cutting operation that have the alpha of 10 degree, the TO is 0.5, the TC is 1.125. During this cutting operation, the cutting force and thrust force measured during the orthogonal cutting operation to be 1,559 Newton for the cutting force, and the thrust force as 1,271 Newton. The width of the orthogonal cutting operation was 3 millimeters. In addition, the volumetric specific heat of the work materials is 3 multiplied by 10 up to power minus 3 joule per cubic millimeter degree, and the thermal diffusivity of 50 multiplied by 10 up to power minus 6 meters square over second, or 50 millimeters square over second. Now, these specific heat and the work material is going to be for the next equation. However, you can see that by now we found the shear plane angle and shear strain in the operation. We found the shear strength and the work material, and we found the friction angle and the coefficient of friction. So today, in this question now, we need to find the cutting power and the specific energy in the machining operation if the cutting speed is 100 meters per minute. So again, we need to give you an introduction about the power and energy relationship. So we know that the machining operation requires powers, and the power to perform the machining can be computed simply by having the cutting force multiplied by the velocity. We know that the power is the force multiplied by the velocity. So here we have the cutting force multiplied by the cutting velocity. The unit, of course, is going to be Newton meter over second, and this will make it the watt, which is the unit power. So the PC is the cutting power, the FC is cutting force, and the V is the cutting speed. If I get to need to calculate this power in horsepower, then simply I get to do the calculation as the cutting speed, cutting force multiplied by the cutting speed divided by 33,000, and this will be in horsepower. Remember that this cutting force is going to be in pound force, and the velocity is going to be in feet per second. We have gross power to operate the machine tool, or the PG or the HPG, is going to be given as the cutting power calculated divided by the efficiency of the motor, which is going to be something about 95%. The unit power in the machining, which is useful to convert the power into a power per unit volume rate of the material cutting, and it's called the unit power PU, or the unit horsepower HPU, and this can be found by dividing the cutting power by the rate of the material removal, okay, which is the how many cubic millimeters we are going to move per seconds or per minute. The specific energy in the machining, where you're going to have unit power as known as specific energy U, and this U is going to be equal to the PC divided by the rate of material removal, or it can be simplified to be equal to the cutting force multiplied by the cutting velocity divided by the cutting velocity multiplied by the initial thickness multiplied by the width. So the unit for that is going to be joule per cubic millimeters. So the velocity we're going to use at the top is going to be in meter per second, but the one we're going to use in the bottom is going to be in cubic millimeters, millimeters per minute. Okay, so let's start to do the calculation using the given data. So now we have the cutting force, we know the width, we know the value for the velocity, and let's start to do. Okay, so we're going to use the parameters given to us to calculate the power of the cutting. So the power in the operation estimated by the cutting power is equal to the cutting force multiplied by the cutting velocity. The cutting force is 1,559 Newton. The velocity is given to us as 100 meter per minute. Okay, so now we do have a given parameters. We need to find the cutting power in watt. So the watt is Newton meter over second, so the velocity should be converted to meter per second, and it's going to be simply the cutting force 1,559 multiplied by the 100 meter per minute divided by 60 to make it as meter per second. The value is going to be 2,598 joule per second, and this will be equal to 2,598 watt. Now we need to find the specific energy. So we said that the equation is going to be the cutting force multiplied by the cutting velocity divided by the cutting velocity multiplied by the chip thickness, initial chip thickness, and multiplied by the width. Remember something, that the upper velocity is going to be in meter per minute, which is 100, and the one below is going to be in millimeter per minute. So that's means we need to multiply by 1,000. Put all the parameters in, and we're going to end up having the value for the U to be equal to 1.093 Newton meter per cubic millimeters. That's it. That's the value for the U, and we're going to use it for the next part of the question to calculate the temperature difference due to the machining operation.